It's a pleasure to present to this work at City 2021. Sorry, but my English not very good. Come on. BERT SE, this work is about BERT SE, a pre-trained language representation model for software engineering. The authors, Eliane de Bortoli Fávero, it's me, Dalcimar Casanova, both of Department of Informatics of Technological University of Paraná, Curitiba, Brazil. The context. Natural language processing in NLP became a study area very relevant and in recent years. Its applications are present in several areas. For example, search sites, chatbots, and others. In the field of software engineering, SE, NLP applications are based on the classification of similar texts. For example, software requirements applied in tasks of software effort estimation, selection of human resources, and others. Classifying software requirements has been a complex task. The informality and complexity inherent in the texts produced during the software development process. This difficulty occurs mainly because, in addition to not having a standard structure, these texts include a diversity of domain-specific information. For example, source code, links, IP address, among others. The text is directly related to the semantic of word concerning the situation in which it is applied. Thus, in software engineering, it is needed to recognize domain-specific terms and their meaning in each situation they are applied. Many different words, but with the same context. In SE, the application of text representation methods based on the characteristics of each word, for example, bag of words, have several limitations. This characteristics type is not sufficient to discriminate against each user textual requirement. Sparsity, high dimensionality, overfitting. The word embedding methods mainly aim to capture the semantic of a particular word in a specific context. Words to be represented in a dense way and with low dimensionality, facilitating applications of machine learning. Different methods for the generation of embedding from text have been developed, contextless or static, and contextualized or dynamic. Contextualized or dynamic. Produces different vectors representations to the same word in a text, which varies according to its context, and they are able to capture contextual semantics of ambiguous words and to address polysemy issues. BERT models are considered contextualized or dynamic models. It has an adaptation mechanics that is transformer, which allows analyzing the context of each word in a text individually. This allows the method to learn contextual relationships between words or subwords in a text. BERT consists of several transformer models whose parameters are pre-trained on an unlabeled corpus like Wikipedia and book corpus. BERT looks left and right several times and outputs a dense vector representation for each word. Among the work related, we can Bortoli's 2014 address, the task of extracting events from a representation model of a domain-specific dataset. Hello?
Yep, go ahead, please, go ahead.
In biomedical text mining, Jiang and others, 2015, present a biomedical domain-specific words embedding model by incorporating STEAM, chunk, and entity to train word embeddings. Sugatadasa and others, 2017, proposed a new measure of semantic similarity aimed at specific domains. This measure was created by the synergetic union of word-to-vec and lexical-based semantic similarity methods. Among works with focus in SE area, we have the C-word sim, consists in a data set of similar words specific to this SE domain. The similarity characteristics between the words were extracted automatically from the questions and answers available in Stack Overflow. E and others, 2060, explored word embeddings to improve information retrieval in software engineering using contextualized embeddings. Word embedding techniques were also applied to estimate the degree of ambiguity of words typical in the context of computer science. Celefato and others addresses the problem of applying feelings analysis to the discipline of software engineering. And a new approach to recommend that similar bugs was proposed by Young and others, 2016. It combines standard information retrieval techniques and contextualized word embedding techniques. Differentials and advantages of proposal models. The proposal in this paper aims to overcome the limitations imposed by bag-of-words models, especially concerning dimensionality and sparsity. Also offers a pre-training word embedding model, the BERT SE, allowing a multitasking representation of textual artifacts to perform tasks involving NLP in this SE domain. There is no need to train a model from scratch or even have a massive corpus to represent the words and their semantic relationships within that domain. Here is present the fine-tuning process of the BERT base model and generation of the textual representation. First, BERT SE and BERT base are inputs in fine-tuning process, generating BERT SE, generate BERT SE. Then test dataset is input to perform word embedding pooling. The output is sentence representation with BERT SE. The preprocessing datasets used for fine-tuning was used sentence subset of Stack Overflow, taken from the cable repository, totaling 137,474 sentences. Two software requirements obtained from open source projects, totaling 326 requirements from 16 large open source projects in 9 repositories. In total, are 456,500 texts. Performing the pre-training. The method used for pre-training by BERT, run pre-training, became available by its authors. The necessary hyperparameters were informed, the most important being max sec length, defining the maximum size of the input texts, set 100, batch size, maximum load size, set at 32, per use guidance of the pre-trained model BERT base. And epochs number, the standard epochs number of models. Model is 100. This number has even been varied to 500 and on thousands during the experiments. Was applied the cosine similarity measure, given a sentence set regarding to SE, was observed the cosine distance of each sentence concerning the others. The similarity among sentences is given by the cosine distance among mean embedding vectors that represent them. This is made as to the generic model, BERT base, has the adjusted model, BERT SE, obtained from the trained model. Result and discussions present measure of similarity of one sentence of the example SC5 to all others sentences. If the difference is a positive value, then BERT SE has a high similarity values. In this experiment, we measure of one sentence against all in the other sentence. It is observed that all similarities increases when using BERT SE model. Cosine similarity time between sentences in the SE domain, BERT SE and BERT SE. The value of this metric is between minimum 1 and 1. Thus, the closer the cost value gets to 1, the greater is the similarity between two sentences. It is observed that all similarities increase when using BERT model. Here, the mean and the standard deviation for cost difference between BERT SE and BERT SE for all 20 test sentences. It is observed that the average values of the difference are positive in all sentences, favoring the representation given by BERT SE. The standard deviation when compared to this gain is low, which confirms this positive difference. The image present cost differences mean obtained from BERT SE and BERT SE adjusted with different epochs number for all 20 sentences. It is observed that the increase in the epochs number of training did not generate significant improvements in the results, but it was evident that the results are always better when applying BERT SE. This graph shows the percentage of improvement obtained about the representation of sentences by BERT SE model when compared with the cosine similarity values. It is observed that was an improvement in all representation of sentences of use the BERT SE model. The mean improvement rate is 23%, is 30% compared to the initial representation by BERT SE. Conclusions 1. We present the BERT SE, a contextualized pre-trained language model based on BERT. BERT is state-of-art in pre-trained language model, which is destined for textual classification in the field of software engineering. This fine-tuning process to generate BERT SE confirmed the statement by the authors of BERT, Devlin, 2019. That fine-tuning takes only a few hours on a GPU and does not require a very large specific corpus. Fine-tuning is relatively inexpensive. The results shows the BERT SE model surpasses the generic model in all representation tests performed, which results in an average improvement rate of 30% about initial representation given by BERT SE. As the results of the article show, BERT SE behaves very well in classifying sentences in the SE area, even considering their context. Thus, it would be possible to perform several NLP tasks in this area with greater precision. For example, bug classification, software effort estimation based on analogy, and others.